Okay, so it's me again, and now I'll talk about application of system dynamics for real-time cloud environment monitoring and management. So, as I already said, I'm representing sdCloud project, and it's a big open source solution for system dynamics modeling. So, since it's open source and free, we're very picky about how we're using our resources because we don't have unlimited budgets like big companies and so on. So, we need to keep our environment as efficient as possible. So one side of it is to run something on GPUs because it's more efficient, and another is to optimize our existing data set. Can we go ahead? The problem right now is that when we're running a data center, we have set of our servers which are running, they consume this power, they need cooling and so on, but they're not always loaded to 100%. And we need to figure out how can we optimize this, and for that purpose, since we're already working with system dynamics, we decided to use system dynamics models. We developed the system dynamics models which describes our loading across our infrastructure, which depends on how many models are submitted for execution, so how they distributed on the nodes, and how all this can be migrated from one node to another to perform the execution more efficiently. And based on this, we were able to figure out how can we optimize our actual environment. Can we go to the next one? So, so we developed this sdCloud SD model and executed in our environment. And the interesting part is that we were monitoring our environments and we were running this model and so on our own environment. To get some interesting results. Actually, can we go to the next slide? So, the results. In the beginning, when we were just running only the servers which we had in our lab, they always switched on and were always running and so on. So, the darker part of this is actually uptime and so the number of the servers which are running constantly, so 24 hours a day. So, the next chart is actually the chart to which we came. We were taking into account many different things. So we used historical data because we know the historical load distribution. When we just started to work with it, it was just average delay, average number of models submitted for execution we have. So later, when we were using this for some time, we were able to use, for example, weekly distribution because we have a lot of weeks, to find the pattern. Now we actually come to the monthly pattern, and it appears that there is actually a very strong distribution of how users executing system dynamics model over the month. So yeah, we have the big gaps, for example, with the low execution on the weekends. We have more executions on Wednesdays and Thursdays, which is actually reasonable. So after the weekend, Monday and Tuesday, everybody's recovering. Friday, everybody's preparing for the weekend. So Wednesday and Thursday is the most hot days, which we have according to the metrics. And also we summarize this historical data with the models which we have, because we're feeding this model, we're performing the prediction. So because starting and stopping the server, it's not a very quick task. So it takes some time. That is why we're performing the prediction. We're trying to figure out, based on the history and based on what we have right now on the input of our models and on the input of our system, we're trying to predict how it will behave maybe next several hours. So if we predict that the average load of the data center will be low, we're just switching off some servers, and so we're not starting new executions on the nodes which were identified to be shut down, or we're trying to migrate long executions because some executions of system dynamics models takes hours, so 7-10 hours. They're big long models. So such models we are trying to migrate where possible execution to other nodes, and to shut down the servers and just save some time, some power. Actually, we cut our costs on data center support twice. So yeah, and actually I think it's visible from this particular chart. It's about 50% time now our servers is just switched off, not to consume, not to produce the heat and consume electricity. I think it's my time already, no?
We have 10 seconds more.
Okay. So, yeah, thank you very much.